Hey everyone, we are asked to provide the ground state electron configuration of sulfur in the standard notation and noble gas notation. So I recommend you take a minute now and try to solve this problem on your own before we go through the answer together. When finding the electron configuration of an atom, or ion, or molecule, we are being asked where does it place its electrons, i.e. what shells and orbitals are its electrons most likely to be found. So, to solve this, the first thing we need to do is look at our periodic table and see how many electrons a sulfur atom actually has in its ground or unexcited state. Looking this up, we can see that sulfur is number 16 on the periodic table, meaning that in a neutral state, our sulfur atom will have 16 protons in its nucleus, and thus 16 electrons surrounding that nucleus to maintain the neutral charge. Let's also remember that in the past video, we talked about this handy device for remembering which orbitals have the lowest energy, as those are the orbitals that are going to get filled first. As I believe it makes things easier for us, I wrote the Bohr model of sulfur here, and that'll help us keep track of our 16 electrons as we place them into our electron energy level diagram. So, let's start by placing our electrons from the lowest energy state to the highest energy state, as shown by our diagram above. We always begin with 1s, and as we discussed before, it is our lowest energy shell, and with S subshell, it can hold 2 electrons. So, that leaves us with 14 electrons left. Next, following our arrows, we have 2s, which again can hold 2 electrons. Next, we have the 2p subshells, and these subshells can hold 6 electrons, leaving us with 6 remaining electrons. Continuing down our diagram from above, we can see that we have 3s and then 3p. Filling the s orbital with 2 more electrons, we are left with 4 remaining electrons. Then our remaining 4 electrons will be placed into the 3p subshell. All these 3 positions, or orientations if you will, are all equivalent energy states, and therefore it doesn't matter which one has the extra electron. Now that we have placed all of our electrons into the energy level diagram, we can write out the electron configurations. Firstly, in standard notation, we have 1s2, 2s2, 2p6, 3s2, and 3p4. Secondly, we can write out our noble gas notation. The noble gas underneath sulfur is neon. Therefore, we can consolidate this portion of the standard notation and write the sulfur electron configuration as neon, 3s2, 3p4. And there we go. We have just solved for sulfur's ground state electron configuration in standard and noble gas notation. I hope that this video helped your understanding of how to solve for sulfur's ground state electron configuration. If you enjoyed, please like, subscribe, and consider checking out our YouTube memberships by clicking that join button down below. However, if you have any comments, questions, or concerns about the information I provided in this video, please leave a comment down below and I will do my best to address your concerns.